In this video, I'm going to explain rate of change and slope. There are two essential questions for today. The first is, how can you measure how fast the relationship between two numbers changes? And the second is, on a graph, how can you visualize slope? Suppose we measured the growth of a tree over time. So we put it in the ground, plant that seed, and then we wait a year and come back and measure it, and it's grown 12 inches. The next year we come back again, so it's been growing for 2 years, and now it's 24 inches tall. And then we come back after 3 years, and it's 36 inches tall. The question is that growth consistent, or is it fluctuating over time? Is it a stable rate of change, a constant? It is. So that means that the relationship between time and growth is a linear relationship, a linear function. The rate of change is constant. So the way for us to write down or measure the speed at which the tree is growing, or the rate of change, is to look at the change in y and the change in x and write that as a ratio. You might notice that every time the year goes up by 1, which is x, the inches, y, goes up by 12. So how x changes is an increase of 1, and that'll be the denominator of the ratio, and how y changes is an increase of 12, so that'll be a 12 for the numerator, 12 over 1. 12 inches of growth per 1 year. Another word for rate of change is slope. If we graphed the information from that table about the tree, remember that was a linear relationship, a linear function, so the graph would make a line that's growing steadily over time. So for example, in this picture, we've got a line, and the slope means the rate of change between any 2 points on the line. Remember, the numerator is how y changes, and the denominator is how x changes. So you can see these 2 points we've marked on the line. Y is that blue vertical line. That's the change in y from one point to the next. And the pink horizontal line is the change in x from one point to the next. So our slope, or rate of change, will be change in y over change in x. It's almost as if you wanted to walk from one point to the next. First you'd walk some steps up, then some steps over. So let's look at this example, a line with 2 points on it labeled 1, 3 and 5, 8. And we want to find the slope of the line that these 2 points lie on. It's clearly a constant slope because this is a line, so we could pick any 2 points in this line to find the slope. We happen to have picked 1, 3 and 5, 8. Remember, the numerator is change in y and the denominator is change in x. So we want to know how much y changes from 3 to 8. We can find that by counting the number of steps from 3 to 8, so going from 3 to 4, 5, 6, 7, 8, or in other words, just subtracting 8 minus 3. So y has changed 5 units. The change in x, similarly, we want to go from 1 to 5. So we can count those steps, 2, 3, 4, 5. It's 4 steps to get from 1 to 5, or in other words, 5 minus 1. So we found the change in y, we found the change in x. It's 5 over 4. 5/4 is the slope. Now suppose we have 2 points here, but we haven't graphed them. We don't have that visual component, just these 2 points, 5, 3, and 9, 0. And we want to find the slope of the line that they lie on. So we still want to find the change in y and the change in x. So we can go ahead and subtract y minus y. 3 minus 0 is 3. And then in the denominator, 5 minus 9 is negative 4, giving us a slope of negative 3/4. What's important here is that we kept pairs from each point together. So we had 3 minus 0 on the top. That means we had to have 5 minus 9, not 9 minus 5 in the bottom, because 3 and 5 are in a point together. So they have to both be the first number in the numerator and the first in the denominator. We can't mix those up. The fact that this is a negative slope means that if we graphed it, we'd see it going down over time, not up. If you find a positive slope, that means the graph is going to be going up over time from left to right, and a negative slope will be going down over time. If you see a graph that, for example, is clearly going down, and then you figure out the slope and find a positive number, that means there's a problem, and you probably have a mistake that you should check in your arithmetic. Now, what about a line that's neither going up nor going down? For example, a horizontal line or a vertical line. What would that mean for the slope? Let's look at some examples. So the pink here on the left, we've got points 1, 3, and 5, 3, a horizontal line. So let's try to find the slope there. The top will be changed in y, 3 minus 3 is 0, and the bottom will be changed in x. So 5 minus 1 is 4, giving us 0 over 4. Let's pause there for a second and then look over at this blue vertical line. So here we've got 2 points, 8, 6, and 8, 2. So if we want to find the slope, we'll subtract the y's on the top. 6 minus 2 is 4. Then we'll subtract the x's on the bottom. 8 minus 8 is 0. So now we've got 4 over 0. So what's the difference here? The horizontal line, 0 over 4, and the vertical line, 4 over 0. Maybe you remember the rules of dividing with 0. 0 divided by 4 equals 0, and that makes sense because that horizontal line is staying flat over time. It's not growing, it's not falling, its slope, its rate of change is 0. But for the vertical line, we've got a slope of 4 over 0, and you might remember that we can't divide by 0. It's impossible. So this is called undefined slope. There isn't a slope here to speak of because, well, let me ask you this. Is this vertical line a function? It isn't. It pretty clearly doesn't pass the vertical line test. So while all linear functions will have a defined slope, this vertical line is not a linear function and doesn't have a defined slope. So now to wrap up, I've got 4 questions for you, and I hope that after watching this video, you feel like you can answer these questions. The first is, what does rate of change mean? The second, if you have points graphed on a line, can you find the slope from those 2 points? The third, if you're given 2 points without a graph, can you find the slope just from those points? And finally, if you have a horizontal or a vertical graph, can you identify the slope or lack thereof immediately without doing any arithmetic?